All right. Problem number 2 says 5 years ago, David's father was 5 times as old as David was then. 3 years from now, David's father will be 3 times as old as David will be then. How old is David now? So my hint to you would be to define some variables. And use when you define variables, it's a good idea to use letters that remind you of what that variable represents. So I would call D David's age now. Okay? That's, oops, Knox, no. David's age now is what I meant. And, since that's what we're looking for, that's a good one to define. And the other thing that we're working with is David's father's age. So maybe you want to call F, capital F, David's father's age now. So we'll just call that father's age now, okay? And you have to keep in mind which time period we're dealing with, because we have David's father and David, we have their ages now, we have their ages 5 years ago, and we have their ages 3 years from now. So, another thing you might think about too is, okay, so let's look at 5 years ago. So 5 years ago, okay, we don't know David's age or his father's age, but we do know that 5 years ago their ages would have been D minus 5 and F minus 5, right? So David was just 5 years younger 5 years ago, and his father was 5 years younger too. And you might also think about, okay, we also know some information about David's father's and David's ages 3 years from now. So let's look at what that would look like. So 3 years from now. Okay. David, what's David's age 3 years from now? He'll be 3 years older, so it's D plus 3. Okay. So if he's 8 years old now, he'd be 11, right? So, and his father's age, he'll just be 3 years older too. So defining those variables and then shifting those variables into the appropriate time frames in which we know the information, because we know some information about David's father's age and David's age 5 years ago, and we also know something about David's father's age and David's age 3 years from now. So we have to make sure we use the appropriate variables when we relate the two. So that's my hint to you. That gets you started. And so if you want to stop the video and work some more on it, go ahead. Otherwise, I'll give you the solution. All right, so we're given, first of all, 5 years ago, David's father was 5 times as old as David was 5 years ago. So we can say, okay, so we know David's father's age 5 years ago, F minus 5, was equal to 5 times David's age 5 years ago. So that's 5, but not times D, it's got to be D minus 5, because we're dealing with his age 5 years ago. Okay, so we can write that equation. All right, we don't know F, we don't know D, but we have this relationship. We also know that some information about what's going on 3 years from now. So 3 years from now, David's father's age, so with 3 years from now, David's father's age will be F plus 3. And David's father will be 3 times as old as David will be in 3 years. So 3 times D plus 3. Okay? So what we've done is converted our two statements that give us information about David's age with respect to his father into equations. Okay? So does that make sense? You can see David's father 5 years ago is equal to David's age 5 years ago times 5. And here we have David's father's age in 3 years is 3 times David's age in 3 years. Okay? So we've just converted those statements into equations. Now there's a number of different ways we can do this. But what I think I am going to do, I'm going to just rewrite this. F minus 5 is equal to, I'm going to use the distributive property. And I'm going to take 5 times both of these things in the parentheses. So that makes it 5d minus 25. Okay, so that gets rid of the parentheses. Same way over here, I can write f plus 3, just repeating what's already there. And then I'm going to use the distributive property and take d times 3 and 3 times 3. So I'm going to get 3d plus 9. All right. I'm going to scroll down and give myself a little more room to work. All right, so let's keep working with these equations. So I'm going to try and get all the variables onto one side. And I can see if I add 25 here and add 25 here, I'll get a positive number. I like positive numbers. So the 25s will, negative 25 plus 25 is just going to be 0. So that goes away. And when you have 25 minus 5, you have 20. Okay, so I'm just going to write that down below, 20. I'm also going to subtract f from both sides. So minus f, and I'm going to put it over here. I'll just put it here, minus f. Okay, so when I subtract f from f, I get 0. So all we're left with on this side is 20. And this went away. And so now we have 5d minus f. Okay? Now you'll see where I'm going here in a minute. I'm also going to do the same thing over here. I think I'm going to subtract f, minus f, and minus f, so that this becomes 0. And here we have a plus 9. I'm actually going to subtract 9 from both sides, minus 9. So we end up with negative 6 is equal to 3d minus f. Okay. So now I'm just going to rewrite these. I can kind of summarize what I got here. So we have 20 is equal to 5d minus f, and we have negative 6 is equal to 3d minus f. Now I can actually add those two equations together, but actually just adding them doesn't get rid of it. What I want to do is really get it down to one variable. And I can see that if I take the negative of this whole thing on the bottom here, if I take the negative of that whole thing, then the negative of a negative 6 is positive 6. And the negative, I'm actually going to make that a plus, and then I'm going to, a negative of a negative, the negative of 3d is negative 3d, and the negative of negative f is a positive f. So now I've distributed the negative sign inside here, so I don't need it outside anymore. Okay, do you see what I did there? I took the negative of everything on the bottom. So the equality still holds, because I did the same thing on both sides. So this is still a true statement. And but the nice thing there is that if I add these two equations, I get 20 plus 6 is 26. I get 5 minus 3, which is 2d, 5d minus 3d, I should say. And negative f plus f is just 0, so I get 2d is 26. And if I divide both sides by 2, I can get d by itself. So d is equal to 13. And we define d as David's age now. So d is 13. So David is 13 years old. Okay? Cool. So that is our answer. And we can actually take this a little further if you want. It kind of helps sometimes to check your answer too and see if that really makes sense. So let's see if we can find his father's age. If David is 13 years old, then we can take that D equals 13 and we can plug it back into any one of these equations up here. But let's see, what's a good one to do? What if we just plug it into, let's do this one. We had negative 6 equals 3D minus F, right? So if I plug negative 6 equals, and if I plug in 13 for D, whoops, I gotta put in 13. Alright, 13, we're just plugging in 13 for D, and then that's still the minus F. So all we need to do now is if we take 13 times 3, that gives us 39 minus F equals negative 6. So I can actually now, I kind of want to know the positive of David's father's age. So why don't I just add F to both sides? Let's say plus F. That gives us an F over here on this side now. And I can add 6, and I can add 6. So again, I'm doing the same thing to both sides of the equality, so the equality is still true. So when I take negative 6 plus 6, I get 0. So I get F is equal to 39 plus 6, which is 45. And F minus F is just 0. So David's father is 45 years old. Okay, so let's take a look at what, based on what we were given. 5 years ago, David would have been 8, and David's father would have been 40. So 8 times 5 is 40, which is what we were given, right? That David's father was 5 times older than David. 3 years from now, David will be 16. 3 years from now, David's father will be 48. So 3 times 16 is 48, and so it checks out. So you can actually, you can check your work, make sure you got the right answer. But the question asks for David's age, and that's David's age.